welcome to Tech Talk Thursday, Season 5, Episode 2. Delighted to be joined by Don Naugler from VJ Electronix. VJ Electronix are well known in the industry for their Summit rework systems and their X-quick X-ray component counters. Recently, however, they made the move into mainstream X-ray systems with the new APOGEE 90 at-line X-ray system. So that's the system we're going to be talking about today, and welcome, Don. Nice to see you.
Thank you very much. It's good to see you as well.
Okay. So, you know, you've got quite a history in X-ray, but I mean, this system, as I understand it, is a 2 or 2.5D X-ray system. Let's start out by maybe describing where you see its place in the market.
Sure, yes. We developed the APOGEE to be a cost-effective tool to be placed on the production floor, basically what we're terming at line. It's not an inline process. It's not intended to keep up with the beat rate of the line, but it's intended to provide both manual inspection, spot checks, quick inspection of certain areas of interest, or fully automatic inspection routines where you can program inspection of whatever components you need to see, typically BGAs or other bottom terminated devices, power devices, that sort of thing. So it's designed to be used in a production mode where you're pulling out only a small number of boards to inspect, just to make sure the process is in tune. Or if you have a question, it's also used after rework. And that's how we got involved in the first place with X-ray, is because of our rework background, inspecting the rework after rework is complete to make sure that the solder joints are as expected.
So, I mean, one of the main reasons that people obviously invest in X-ray systems as part of their line these days is, of course, because of the number of bottom terminated components and the ability to see specifically things like BGAs and measure voiding and that type of thing. Do you have the capability within the system to do that?
Yes, absolutely. You're right. One of the first drivers for X-ray inspection was BGAs, and now the bottom terminated components have really proliferated. Yep. There are cases where 3D is certainly an advantage, where you can look and determine exactly where in the plane or which plane the void occurs and so on. But the biggest advantage to 3D is, of course, double-sided boards and trying to separate the top side, for instance, from the bottom side. And in some cases in two-dimensional X-ray, the solder joint that you're looking at may be obstructed by the component on the bottom. And that's where 2.5D comes in, where you can use off-axis or oblique views to work around that obstruction and basically still be able to see the entire solder joint just by setting up the proper angles. And so the APOGEE does have that capability for the oblique viewing.
What sort of level of oblique viewing, what sort of angles can it get to?
Typically up to about 45 degrees, and that is going to handle most cases. I know that the lab systems can typically do much higher, but for most production uses, we find that 45 degrees meets the needs of the customer.
Right, okay. So let's talk about the tube system that's in it. Is it an open or a closed system?
We use in the APOGEE exclusively closed tubes. The big difference between the open tube and the closed tube is going to be the resolution and magnification. So certainly there are benefits, especially if you're doing failure analysis in high magnification. But in the production, we typically see lower magnification levels. And that's because you don't really need to see the most minute details, but also it's going to help things go faster. So a field of view using maybe 10x or 15x geometric magnification is going to get you several solder joints into a single field of view. The other advantage, or obviously the advantage to the closed tube, is primarily cost. A closed tube system, the actual components are going to be about 1/3 the cost to 1/4 the cost of an open tube system, which is going to impact the price of the total X-ray system by maybe 50%, almost up to 2x in some cases. The other advantage of the closed tube is the fact that it's maintenance free. In order to achieve the added, the performance of the open tube, you basically have to maintain it on a regular basis. You have to do things like rotate or replace the targets as they wear out and that sort of thing. So this adds a lot of scheduled downtime that you can avoid with a closed tube system. So between the maintenance-free aspects and the cost is the reason we went closed tube.
Okay, so I mean, what is the average tube life before you need to do a changeover?
The typical rule of thumb is a number of 10,000 hours or more. And so obviously that impacts different people differently. So in a high volume environment, that's typically going to be 4 or 5 years to as much as 10 years of actual, usable life out of the tube.
Right. And what about the changeover? Is that a quick process? Is it an easy process?
Yes, it is. Changeover, I won't say it's quite as easy as changing a light bulb, but it's basically you take the entire module out. It's one field replaceable unit, plug and play. And, granted, it is more expensive than replacing just a target on an open tube. You're going to be looking at a higher replacement cost. But then again, in some cases, tubes can be refurbished. So it's not always a matter of totally replacing the tube. The refurbishment, of course, has to go back to the original manufacturer to be done.
What's the target size like inside a closed tube like that? Is it bigger or smaller than you would get in an open one?
Typically in a sealed tube, it is going to be much smaller. Because it is fixed, the vacuum is totally sealed. So, we refer to it as a sealed tube, obviously. And in the case of an open tube, it's going to, be something that can be replaced or repositioned, because if you have a damaged target, then you can rotate it and move the damaged area out of the useful area and continue to use it. But then you've got to create the vacuum again. So there's vacuum pumps and seals and high voltage cables that you have to deal with. And that's why you've got a much higher maintenance in the open tube systems.
Okay. So what sort of resolution then are we getting down to then using this system?
Well, that depends on the spot size. The APOGEE 90, for instance, has a 4 micron spot. A 130 system will typically have somewhere between 5 and 8, sometimes a little bit higher. And the other thing to keep in mind too is the spot size and the power that's being applied are related. So when we talk about a minimum spot size of 4 microns, and that's going to be on a low power setting. If you have a fairly high density board, a thick board, you're going to need to turn the power up on your X-ray source. And the X-ray systems will automatically adjust that spot size, because you can't force too much energy into a small spot without potentially damaging the target. And that's the reason the open tubes have smaller spot size, because they are maintainable and you can afford to burn out a target, in a month's use or something like that, as opposed to having to maintain that target throughout the lifetime of the tube.
So it's my understanding that this tube that we're talking about now is a 90 kV tube, but you've got plans to upgrade it to a 130 in the future.
That's right. It'll actually be a different model, but the 90 kV is, it's targeted towards lighter, smaller boards. Something you'd see in portable market, consumer products, medical applications, and even in some cases, semiconductor packaging can be done, because the resolution on the 90 kV is actually a bit higher. And then the 130 will follow, and that'll be for more general purpose like computing and networking and that sort of thing, where you need a little bit more punch to get through the thicker boards.
Right.
Co-Young is leading a smart revolution that will change the world of electronics manufacturing. Based on our pioneering True 3D measurement-based inspection technology, we revolutionized the solder paste inspection market to such great lengths that 1 in 2 SPIs sold today is from Co-Young. Building our SPI technology, we expanded to automated optical inspection, also known as AOI. Every year, we introduce new award-winning innovations and have proudly earned the respect from thousands of customers across diverse industries. Aside from our R&D center in Korea, we have research facilities focused on artificial intelligence and deep learning across the world to help us further develop proprietary AI technologies for your challenges. With our global network of sales and service centers, we aim to respond quickly to your needs and to deliver the highest level of customer satisfaction.
So the sample size, what would be the maximum sample size you would be looking to inspect?
Well, we have a sample size of 18 inches in the APOGEE, which we think handles probably 90% of the market needs at this point. So we're not aiming for the one size fits all, because then obviously the overall system size gets much larger as you need to handle larger samples. So we've chosen this as the sweet spot to hit most people's needs.
Okay. And so, how accurate is it, and is it repeatable? Is it a repeatable step and repeat system?
Yes. Well, I think in terms of the data that you get out of it, it's highly repeatable. We're actually working with some of our beta customers now, looking at repeatability, gauge R&R, and that sort of thing. So the measurements that come out of it, the percent voiding, the area analysis, that sort of thing is very, very repeatable. And admittedly, the motions are not necessarily as repeatable as they would be on an inline system, because we're not looking to have very fast motions. We're not looking to do a lot of regions of interest in a very short period of time. So we can afford to be a little bit looser, and then have the algorithms actually find the components within the field of view. So X and Y accuracy is not super high. It's decent, but the reporting will be very accurate.
Okay, interesting. So, I mean, looking at the applications for this, I mean, where do you see its sweet spot? You mentioned that you could use it post rework. Are you thinking in terms of markets, you'd be more for consumer products and this type of thing? Or would it be something for high reliability stuff like automotive, for example?
Well, you do mention consumer products. I think that is really the sweet spot. Anything that's smaller, automotive, high reliability is not the issue so much. It's really the size of the assemblies, the thickness. So when you get into things like automotive, the assemblies tend to be much more dense and heavy and sometimes encapsulated. So that's when you need the higher kV, the higher energy systems. Right. So the 90 is definitely aiming towards the consumer products, the portables, anything from PDAs and cell phones, medical, when we're talking about portable medical devices or implantable devices. But the 130, which is right behind the 90, will be more suited for the automotive and computing and heavier assemblies.
So it's an interesting area. I mean, some would say that the X-ray market as such is commoditizing quite a bit at the moment, the number of players that are in it. So it's kind of interesting. I think you picked your spot, and you probably picked your price point too. And it sounds like quite an interesting offering that you've got. So, I wish you the best of luck with it, Don.
Well, thank you. Yes, it is definitely becoming more uniform in the offering. Won't quite say commoditized, but getting that point. And so we hope that we can bring our customers some advantages, not just in price point, but in the software and some of the features that are kind of in the background compared to a very simplistic X-ray system. So that would be the programmability, the automatic analysis for many types of components, features like we have something called automatic defect enhancement, which can really take advantage of the fact that we have 16 bits of data, and the monitor that will be displaying this is capable of only a fraction of that that contrast. And the automatic defect enhancement will basically make the visible image much more usable on a monitor. So it really makes subtle defects pop out. So things like that, I think, bring the added value to the APOGEE compared to a very basic X-ray machine.
Absolutely. So it's an at-line system. Does it integrate in any way with any of your reworks, or even on the software level?
Only in the programmability. So it's not quite ready for prime time yet, but we're working on a interface where we can bring in things such as Gerber files so that we can quickly program a new board. We do have the ability to export the reports in like a flat file or an XML file, all the images. So we can help our customers collect SPC data, and traceability of automotive and medical components is very, very important. So we're supporting that as well.
Right. Super. Well, as I say, I think you seem to be hitting the right spot with this. So we wish you every success with it, Don, and thank you for coming in and telling us about it today.
Well, thank you, Trevor.